Good evening, student friends and Professor Muniswamy. And I thank at the onset to Professor Muniswamy for giving me an opportunity to interact with you in this research methodology, particularly the correlation and regression analysis.
Thanks.
So this correlation and regression analysis is one of the most important concepts in data analysis. Wherever we may be doing statistical analysis with respect to the data, there usually we have to go through this correlation and regression analysis. So this topic is very, very important and very useful for doing the research in either qualitative or quantitative analysis. And it will be useful for predictive modeling as well as descriptive modeling also. So in both ways, this correlation and regression analysis will be very useful. And now we are discussing this correlation and regression analysis. Not moving. First, let us discuss why do we do this correlation and regression analysis. That is to see that to establish the relationship between the variables. That is the first one important thing. Usually, in our research, what we will be doing that we will be considering several variables. In that, what exactly we want to do with that variable? We want to establish the relationship, how one variable is influencing the other variable. For example, if we see the supply and demand, income and consumption, diet intake and weight. These are the various variables when we look into that. So here, when we want to analyze how the weight is of an individual increases with respect to the diet intake, in the presence of other variables, in the absence of other variables. This is very important consideration. So we all know that one of the general perception that if diet intake is more, the weight will be more. We put up more and more weight. This is a perception or a reality. That is also another important consideration. So statistical analysis will be very helpful to study that and to establish what is exactly the relationship between the variables. For that, this will be very useful. And not only that, the relationship is very much important to analyze further and further, because the hidden knowledge within the study that can be established by properly identifying the relationship between the variables. If the relationship identification is not scientific, then whatever relation we are maybe thinking about, that may not have a validity. So, one has to be very careful when we are establishing this, and we have to use sound, robust scientific methodology. For that, this regression analysis is very, very helpful. It may be in any discipline. Maybe in life sciences, physical sciences, chemical sciences, environmental sciences, or any other area, social sciences or managerial sciences or engineering subjects. They have to establish the relation between the variables. And is very simple and very easy if we can understand this regression analysis. Another very important consideration is reducing trivial many to vital few. What is this trivial many to vital few? When we look into that, for every query in mind, when we want to analyze, when we want to solve that query, what we have to do? We have to identify the variables. When we are identifying, there are several variables which are responsible for a response. So the response is influenced by several many variables we may think about. When we are conducting a brainstorming or interactive meeting with the stakeholders, or we are conducting the experimentation, we may be having trivial many variables in mind. For example, the marks obtained in a particular subject is highly influenced by several variables, like the study hours, the direct contact hours with the teacher, the library spending, the study material we have prepared, the interaction we have with our teacher, the type of question paper, the skill level of the candidate, or the knowledge level of the candidate. Like this, if I go on identifying the variables, there may be several variables which may come in our mind and also in our practice. Each variable is very important, looks to be very, very crucial for the marks obtained in the class. But only few variables which are very, very important, which have a major response like the mark obtained. So those vital, very vital, two variables are to be identified in order to analyze more appropriately and more effectively. Because even if you identify some 20, 30 variables, all these may not have very significant influence on the response. Only few will have that significant influence. So those few variables we have to identify. We can identify, or we can do that, which are very crucial and which are very, very important. Those important variables that are influencing this response can be easily identified by our regression analysis. By conducting the regression analysis, we could be able to identify that very, very important vital few variables which have a significant influence on the response. This is possible only by conducting this regression. And this is very much important for any research, because when we have several variables, we may be in a confusion state. Which variables are to be controlled? Which variables are to be analyzed more effectively? Which are to be given more importance? If we ignore the very, very important variables and give more importance to the variables which are very insignificant, there is of no use in our study. So we have to identify and we have to get that vital few which are very influencing the response. Another very important consideration why we go for regression analysis is to understand the processes. Whenever we want to have the study of a process or a phenomenon, what we have to do? We have to understand properly. Proper understanding means establishing the relations, identifying the variables, and also the fact that is lying with this variable. So to understand the processes more significantly, these are very, very important. The process descriptive, explicitly or implicitly. In both the ways, we can understand the processes more effectively if you can study the regression analysis. For that, one has to take care of regression analysis. Another very, very important in many of the things is forecasting the variable. Forecasting is, what is forecasting? Estimating the future value of a variable. Estimating the future value of a variable is known as forecasting. So, to perform the forecasting, one has to conduct this regression analysis. By this forecast, to have proper planning, to understand and to take a decision, to take a right decision at the right time. For that, the forecast is very important. Forecasting is used in several places, several times by almost everyone who is in decision making. For proper allocation of funds, the government has to forecast the requirements. For budgetary allocations, one has to look into this forecast, the variable. Not only that, in many of our experiments, what is going to happen in future with respect to the particular variables under study, very important. The forecasting. So, regression analysis is very helpful and very useful for performing the forecast of the variable. Another important consideration is to identify the factors affecting the response. This is very, very important. We have to do the factors. Which are the factors that are affecting the response? Not the variables alone, the factors. So, to identify the input variables more effectively and their influence on the response. How much influence of one variable on the other? If I change the input variable by 1 unit, how many units of change I am going to get on the response? This is very much important for designing, develop the processes and products. So, to have the influence, the factors which are affecting the response, and to measure the response in terms of the changes in the factors, that is very important. That can be done by regression. Hello? Hello? Okay.
Sir, continue, sir. Continue.
Okay. To provide baseline for process performance. To provide a baseline for the process performance, one has to conduct the regression. What is this baseline mean? That is nothing but of benchmarking. Benchmarking of the variables is very important. Suppose I want to take care. How can I fix the first class percentage? We say 60% above first class. Why 60%? Why not 70%? Or why not 50%? This question will come. There will be scientific, robust, reasonable logic behind that to fix the golden standard of that. We say a student is a first class person if secure above 60%. So 60%, how it is decided? That is the benchmark. How that benchmark is taken? The benchmark is taken care by doing previous data analysis with respect to this regression analysis. Regression analysis will be very, very important because that will talk about the performance of the candidate. When we talk about he is a first class candidate, that is reflected to the intelligentsia and performance of the candidate. The performance of the candidate, how do we measure with respect to that? How do we scale them? To scale this, the benchmark is very important. To bring this benchmark, several historical data analyses at different environments, different conditions are to be performed. And after performing that, by comparing all these different environments and different systems, it is brought to the consideration is 60% and above is to be considered as a first class student. That is what the benchmarking was fixed. Similarly, in several places, we have to fix the benchmark or baseline. Unless that benchmark or baseline is there, you cannot take it to that. So, for doing that, this regression analysis is very, very important and very useful. Not only this, these are only a few advantages of doing the regression. There are several other situations like optimization. In optimization, we have to do this sort of regression analysis. So, the optimal value, what is the best set and best combination of the variables to give you the optimal response, that can also be analyzed by doing this regression. So, regression analysis is helpful during the optimization of identifying best set of variables which collectively provide the optimal response, either maxima or minima, that can be seen. Also, there are several other that can be taken care and using this regression analysis. So, friends, this regression analysis is very, very important and very useful for research methodology as well as data analysis. What is this regression analysis talk about? So, the regression analysis will be speaking about two things: identification of the variables and establishing the functional relationship. Because Y is the output variable. The output variable is influenced by input variable, key performance input variable, KPIV we call. Y is influenced by X. X is the input variable, Y is the it's between that in mathematical functional form. That functional relationship, what type of functional relationship exhibits between Y and X, that can be taken care. To understand an output, we have to focus on our input variable. That is very important. So for that, we have to do this regression, functional relationship. So regression analysis is nothing but of establishing the functional relationship between input variables and output variables. That is very important. So, to establish this functional variable, let us look into this: what is Y and what is X. So, Y is a dependent variable. That dependent variable is influenced by independent variable, X. Independent variable, we call it as X. Dependent variable is Y. For example, already I have mentioned that when we are having spending, the spending is dependent on your income. Income is an independent variable, spending is a dependent variable, consumption is a dependent variable. Also, weight, individual's weight is your dependent variable. Diet intake is an independent variable. How much food we are taking, that is influencing your weight. So, Y and X. One is a dependent variable, the other is an independent variable. Similarly, Y can also be identified as an output of the process, output of the product, output of an individual performance. The output are dependent on your input. How much input you have kept, that is very influencing the output. So how much input we are giving, based on that only the output will be there. So output is influenced by input. For example, the marks obtained is dependent on the study hours, number of study hours. If we all know that output is nothing but of the marks obtained, input is the study hours and lecture hours, contact hours with the teacher. So all this will be matters. These are all input variables. Also we have response. Response is in Y is the response and the variable is X. Y is influenced by X. So response is influenced by your variable X. And dependent variable may be effect. Y is effect. For every effect, there is a cause. X is cause. If there is a cause, then only there is an effect. So the cause and effect. That's why regression analysis is also known as cause and effect analysis. Also it is known as input-output analysis. And not only that, Y is the symptom, X is the problem. For every problem there is a symptom. To control the symptom, you have to control the problem. You have to analyze the problem. You have to solve the problem. Then only the symptoms will be completely analyzed. So, to have analysis on Y, the dependent variable, you have to focus on influencing variables or input variables or the causes that are known as your X independent variables. So, Y is influenced by X. That influence is measured through a functional form. That functional form is F. That is known as functional relationship. So, establishing the functional relationship between Y and X, dependent variable and independent variable, that is what we have in our regression analysis. And to start with the regression analysis is important. Correlation analysis is important. First we have to study the correlation, then we have to go for regression analysis. The first step in regression analysis is studying the correlation. Correlation is a statistical tool which studies the relationship between two variables. So the correlation will talk about the relationship between two variables. If one variable changes, the other variable also changes accordingly. Then we say there is a correlation exhibits between these two variables. That is, the two variables are said to be correlated if change in one variable results in correspondence change in the other variable. So, change in one variable reflects on the change in the other variable. Correlation analysis gives an idea about the degree and direction of the relationship between two variables under study. What is this degree means and what is this direction mean? The degree is how much influence of one variable on the other. How much? It may be high, may be low, it may be moderate, or it may be no. So there are four categories. We can say the variables are highly correlated, the variables are moderately correlated, or the variables are low correlated, or there is no correlation among the variables. So, the degree of that correlation, degree of the relationship is studied by this. And also, the correlation between two variables can be studied by sound statistical. And I have talking about the degree. And also there is a direction. Which direction the correlation will be? It may be positive, it may be negative. How do you say it is a positive? The change in one variable also changes in the other that we have seen. So, if one increases, the other variable is also increasing. Increase in one independent variable results the increase in other dependent variable. Then we say that they are positively correlated. And then what is negative? Increase in one variable results the decrease in other variable. That reduces the other variable. Then we say it is negatively correlated. So there may be a positive correlation, there may be a negative correlation. So the correlation direction is very also important. Maybe a positively influencing, maybe negatively influencing outcome. Because we can see, suppose a vehicle, a car, a four-wheeler, depending on its horsepower, its mileage. Horsepower is more, mileage will be less. Horsepower is less, mileage will be more. Depending on its weight, mileage. If the vehicle is more weight, mileage is reduced. If the vehicle is less weight, mileage is. So there is a positive relation or a negative relation. So how to study this relationship? How to identify either its degree or its direction? That can be done by four methods in statistical. One is known as second one is Carl Pearson's coefficient of correlation. Third one is Pearson's rank correlation. Fourth one is correlation ratio. And of course, these four are very important, usually considered. In addition to that, there is also Tau's correlation and correlation ratio. These two are also be very considered. The simplest one is scatter diagram. What is this scatter diagram talk about? Before I do that, let me say a simple consideration. Let me caution you. When you are doing this correlation analogy, you should be very careful because the data analysis does not always give the right perception. Subjectual understanding is more important. One must have good knowledge of the subject. Then only one has to consider the data analysis. Without having any knowledge of this subject, if you start doing data, suppose if you find a strong association, high correlation, may be observed to unrelated variable because it is only a data. But if they are meaningfully connected or not connected, how do you understand? By subjectual consideration. Your subjectual phenomenon is supported by statistical analysis or data analysis. Data does not give unless you have a subjectual knowledge, the fact. Fact can be considered by this. Because the influence of two variables may be caused by influence of the third variable. There is a third variable which is influencing the dependent variable. As a result of it, if you analyze the first two variables, you may get a high correlation, but first two may not have a high correlation individually. If you eliminate the third variable, it may not come into that. So, it is very important. You have to see what is of the other variables when you are doing this correlation analysis. And maybe it is purely chance the data analysis you are doing, the correlation may be appeared. It is only a mathematical relation, but it is not established knowledgeable subject matter in that. So the subject matter is very important for judging this. For example, if you consider this, a correlation, suppose if you find daily sales of umbrellas and daily traffic accidents. Sales of umbrellas no way influence traffic accidents. We all know. But if you take the data at a busy junction or at a particular city in a rainy season, there may be more sales. Rainy season, there may be accidents. Because of the rain, the intensity of the rain, the third variable. But if you take, there is no rain, then sales of umbrellas are no way influenced by number of accidents in that region. Both may be influenced in the presence of rain. Rain is there, more sales of umbrellas and more accidents may be there. So, the relationship between, if you consider alone these two variables, sales of umbrellas and number of accidents, the correlation that appears is a spurious correlation, known as a nonsense correlation. There is no relation between the sale of umbrellas and traffic accidents. But in the third variable is very important. That is, rain. Intensity of rain is influencing the sales of umbrellas. Intensity of rain influencing the number of accidents in a traffic. So these are very important. That one has to take care. When we are analyzing this correlation analysis, we must have a sound knowledge of the subject matter. That is very, very important. One has to take care. Now let us look into the methods of analyzing the correlation. One of the important methods that we are considering is nothing but of scatter diagram. So, scatter diagram, when we look into that, what is this? It is a graphical method, a graph plotting the dependent variable on the y-axis and independent variable on the x-axis. So the point is plotted in the graph map, y-axis and x-axis. If you plot that, then you will get points, scatter of points. This scatter of points will talk about the relationship between the two variables. Whether the relation is high, low, moderate, the degree of that, as well as direction. So, scatter diagram identifies the vital few parameters that can play dominant role in determining the final value of the product parameters of the. So, if all the points are very dense and they are like a straight line, and we say it is positive correlation, there is high correlation. Also, we can identify if there is a poor correlation or no correlation by scatter diagram. This, if you look into that. If you see the first one, that is linear, perfectly linear. So there is a positive perfect correlation. One variable increases, the other is also increasing. The dependent variable is increasing, as and when independent variable increases in the same way. Then we say it is perfect positive correlation. The second one, if you look into that, in the first row, there is a high degree positive correlation. This is also like linear and they are scattered. But the scattering is more concentrated at that line. So it is high degree positive correlation if that looks like that. And if you see the third one in the first row, up row, there is a weak positive correlation. Because they are on a straight line increasing fashion, one increases, the other is also increasing, but scattering is more. So, we can have this weak positive correlation. There is a weak positive correlation. Similarly, if you look into the second row, there is a straight line, a linear relationship, but the relation is inverted. That is perfect negative correlation. Why negative? One variable increases, the other variable is decreasing. X increases, Y is decreasing. That is clearly seen there. They are linear, perfectly linear, but one increases, the other is decreasing. Therefore, there is a perfect negative correlation. And look into the next one. High degree negative correlation. This is also linear, but they are scattered. So high degree, scattering is more concentrated towards the line, linear. So, high degree negative correlation. And if you see the third one, here weak negative correlation because one increases, the other decreases, but the spread is more wide spread. So, weak negative correlation. This scatter diagram easily identifies. It gives a bird's eye view of the relationship between the two variables. And similarly, if you look into this, what do you talk about this correlation? There is no correlation. It is like a circle. There is neither increasing nor decreasing. It remains the static. So, we say there is no correlation. The scatter plot is like this. There is no correlation among the between the variables. And we can do it by SPSS package. Now, the statistical packages like SPSS, Minitab, Flash, there are several other packages that are very useful to do this correlation analysis. Now, the statistical analysis is just button press. Single pressing the button after entering the data. You have to choose and do that. That can be done in this. If you do the scatter analysis here, if you use SPSS package, you can drive in this way. There are graphs, then legacy diagram, then scatter and plot. That automatically gives you this type of. Here if you look into this, what do you say? There is high positive correlation. Because it is in increasing fashion, one variable that is X is number of employees, cost of the firm. Number of employees are more, cost of the firm will also be more. So if number of employees are increasing, cost of the firm is also increasing. So that we can easily see. That can be seen by this. Scatter diagram. This is one specific and specimen of it, which is the output given by the SPSS. And then a very important mathematical formulation, the correlation, known as Karl-Pearson's coefficient of correlation. Karl-Pearson's coefficient of correlation is a mathematical measure for measuring the intensity of the. Before I say this, one important thing one has to remember. We can use this. This is a parametric method we call. Why parametric method? Here we make an assumption on the linearity of the relationship. if the relation between the two variables is linear, only we have to use Karl Pearson's coefficient of correlation. If the relationship is not linear, using Karl Pearson's correlation coefficient may not lead proper. So first you have to do the scatter plot, observe that there is a linear relationship, and only you go for this Karl Pearson's coefficient of correlation using this mathematical formula. So this mathematical method for measuring the intensity of magnitude of linear relationship between the two variables is given by, usually the sample correlation coefficient is denoted as R. R is equals to covariance of xy by standard deviation of x into standard deviation of y. In our statistical sense, we know already covariance and standard deviation. That can also be directly computed using the variables directly x and y. We have a set of n observations, xi and yi, I equals to 1 to n. Then R can be calculated as sigma x minus x bar into y minus y bar divided by root over sigma x minus x bar whole square into sigma y minus y bar whole square. So this is the Karl Pearson's coefficient of correlation. Minus 1 and plus 1. Plus 1 implies that there is a perfectly positively correlated. If two variables are perfectly positively correlated because they are on the line perfectly, then increasing, one variable increases, the other is also increasing. Then we say it is perfectly positively correlated, and its R value, if you compute, you will get 1. Similarly, if R equals to minus 1, then x and y are perfectly negatively correlated. They are on a straight line, and if one variable increases, the other is increasing, but they are negative. The relationship is one increases, the other is decreasing, and the relationship is negative. It is minus 1. And R equals to 0, there is no correlation. They are not correlated. So this is what Karl Pearson's correlation. And it can be computed by using a Minitab package. So if you open a Minitab, I advise all those who have undergone this research methodology course, please download one of the packages on demo version in your desktop or a laptop, whatever you have. Demo versions are free of cost, provided for 30 days. Practice all the research methodology methods you got in statistical analysis. You may download SPSS or Minitab easily because they are providing 1 month demo version. This 1 month demo version is sufficient for you to practice and understand and know about the methodology very clearly and tools and techniques. So download that. Either you may download Minitab or you can do that by SPSS. So once you do this, you have it. Or if you have a real data for your project, you may request the statistics head of the department to provide you SPSS in their lab. You may take it to that and do that. But before that, if you do this demo version with that, that will be sufficient for you to do the statistical analysis for all the required work in the project with respect to data analysis. So if you use the Minitab, it is stat, then go to basic statistics, then select correlation. Once you do that, you will have variables you have to identify, which variables you want to take in the spreadsheet. Once you do that, then you will get. So the Karl Pearson's correlation coefficient, if you see this output here, let me tell you about this output. You got this output as the correlation between x and y is 0.911. What it means? How do you interpret? Before you interpreting, you have to go for p-value. Every statistical package will be providing the p-value. That is the level of significance. That is your significant value. Whether it is significant or not. What this means by significant? Because you have taken only a sample of some variables. Here in this case you have only 10 variables. So 10 observations you have taken. You are inferring about the whole population. of X and Y related. And that inference is made for the whole population but based on a small sample. There is a sampling error. So this error, is it be significant or not when we do that? So in the presence of taking a sample and doing that, that can be done by statistical tests. Already you might have been known about it. You are taught about testing of hypothesis. So in the test, statistical test, if you do that, the p-value, if this p-value is less than the level of significance of 5% or 10%, whatever you want to have, then you say this is significant. Here, the X and Y value you got 0.911, the significant value 0.000, which is less than 0.05. So at 5% level of significance, the correlation between these two variables is very significant. Therefore, correlation 0.911 is acceptable and they are positively correlated and they are highly correlated because it is 0.9. They are highly correlated and positively correlated. So this we will do, we can have. But when we go for other method, that is Spearman's rank correlation, when we look into the variables usually will be qualitative variables. Always we may not have that. We may have attributes. Sometimes the attributes, the ranking of the judges and their scores, whether the two judges are correlated or not. Also, there are several other things where we may get the attributes. The relation between these two variables which are given in attributes may be measured, may be analyzed. And in addition to that, very important, earlier we have seen that the Karl Pearson's correlation coefficient is related to linear assumption. That is, if the relation between X and Y is linear and established, then only we go for Karl Pearson's correlation coefficient. In some cases, we may not be able to establish. By scatter plot, we are unable to understand whether it is a linear or a non-linear. If it is not a linear, or it is a non-linear, or we are in an ambiguity to decide whether it is a linear or not, then that assumption is not valid. So we have to go for other method. In such case of a non-parametric method is to be taken care. Spearman's rank correlation is a non-parametric method. This non-parametric method will be helpful even in the absence of that assumption. You can do the correlation analysis. So, Spearman's rank correlation coefficient, we can do that when there are attributes or even if the measurements are quantifiable, directly measured. Even then also you can use, if you are not able to decide the relationship beforehand, the analysis, then you can go for this non-parametric analysis. In such case, what is the formula for this Spearman's rank correlation coefficient? You can look into this. Yeah. What is there? R equals to 1 minus 6 sigma d square by n into n square minus 1, where d is the difference between the pair of ranks. Two ranks we have taken. Between the pair of ranks, what is the difference? That is the d value. And n is the number of pairs, the number of observations. N is the number of observations or number of pairs that can be taken. If the ranks are repeated, suppose sometimes when we are giving the ranks, same rank may be given to two sets of people. Then how do you distinguish? How do you incorporate that? That can be done by adding a correction factor to this. So if the ranks are repeated, any of the ranks are repeated, then you have to take where m is the number of times an item is repeated, ranks are repeated. So here we had the factor m into m square minus 1 by 12 to sigma d square. Sigma d square plus m into m square minus 1 by 12. That is to be taken in the numerator, where m is the number of times an item is repeated. So this we can use the formula. But interpretation is same as your Pearson's correlation coefficient. That is, your R lies between -1 and +1. If it is negative, then there is a negative correlation. If it is positive, then there is a positive correlation. If this is 0, there is no correlation. So the degree and direction we have to interpret in the same fashion. So Spearman's rank correlation can also be calculated using this mini tab. You may select this window, and here you can select that, and you can select the blocks to specify the column for which ranking is to be done. Select the column to store the ranks. Then you have this. You can select and do this. Once you do that, you will get an output in this way. Suppose you got the correlation between two variables x1 and y1. If you see the x1 and y1, what is the correlation it was given? 0.223. How do you interpret this? Before interpreting that, already I have mentioned that you have to see the p-value. What is this p-value here? It is 0.536. So p-value is 0.536. What it is? Already I told the level of significance you have to compare with that. What is the level of significance? 0.05, 5% if you take, or 10% if you take, 0.1. This value is greater than 0.05 or 0.1. In both 5% and 10% levels of significance, this p-value is higher than that. Therefore, even though there appears the correlation coefficient is 0.223, that correlation cannot be acceptable. This is only due to sampling fluctuation, but not of inherent dependence of y on the x. So x no way influencing y. The correlation is not meaningful. There is no significant correlation, and we have to ignore this correlation. Even though it appears that there is a 0.223 correlation between the two variables, we cannot consider that because of the p-value. P-value is very high. So we say that there is no correlation between the two variables. That is our interpretation. One should be very, very, very careful when we are interpreting the inferences, the output. That is very important. Then, what is the very important? So far we have done the correlation analysis. Correlation analysis, what is the major drawback? The major drawback is it measures degree and direction, but it won't do any influence. It won't measure how much influence of one variable on the other directly. Directly you cannot say, suppose I got the R equals to 0.09. I cannot say there is 90% or something in that way. So what I have to do? R is as a measure of strength of linear relationship between x and y, a positive. So what I have to do? I have to calculate very important measure known as strength of the association. What is the strength of the association? That is known as quotient of determination, R square. Quotient of determination is measured through R square, squaring the correlation coefficient. So what is it talk about? The percentage of variation of the response variable that is explained by the other variable, explanatory variable. How much percentage of variation one variable is explained by the other variable. That is defined, that is interpreted by this quotient of determination. That is, suppose in this part, if you see here R equals to 0.8, but squaring it, how much we got? 64. So 0.64. 0.64 means, what exactly it means? 64% of the variation between the two variables can be explained by one variable about the other. One variable is influenced by other with 64%. The remaining 36% is by some other variable, not by these two variables. So that one has to take care. and that can be seen here. Here you can see R equals to 0.967. R square will be 92.7. So what is the percent? 92.7%, because squaring it you may get 0.927. So 92.7% is there. So what is the inference? Almost 92% of variation amounts to the one variable, say water consumed, is explained by outside temperature. Because if you see water consumed and temperature, these are the two variables. If you consider how much water we consume, that is 93% is due to temperature. Temperature is high, more water we have to consume. And there is a 7% maybe due to other reasons. For other reasons we may take 7% of water, but 93% because of the heavy temperature if it is. So correlation analysis, we can also do it by our SPSS package, and it can be done in this way using this part of the thing. We will have, then we will have a correlation, more than one will. Then we can use this. So what is the very important consideration here? Here we have this. The correlation and regression talk about the relationship, but is it be sufficient for our analysis? No, not at all. Why? We want to analyze the response because of the effect or the dependent variable with respect to the independent variable. If I change one unit in the independent variable, how many units of change I can get in the dependent variable? That is very important. So that cannot be done by your correlation analysis. How much? The magnitude, the measurement of influence of one independent variable and the dependent variable is not known directly by your correlation analysis. But that is more important for us, to have a optimization, to have a control, to look into that. We have to take care about that. So for that, we have to do the cause and effect analysis, that is known as regression analysis. So for doing this regression analysis, what we have to do? We have to identify the variables. What are the effects that are caused by this? So causes and effects that one has to identify properly. Once you write it, then only you go for regression analysis. Because it is very important. You have to identify what is a dependent variable, what is an independent variable properly. If you not properly identify the dependent variable and independent variable, because some cases it is not, vice versa is not possible. For example, your expenditure is dependent on your income. Income is an independent variable. Expenditure is a dependent variable. If you have more income, more expenditure you may spend, usually. But vice versa is not true. Income is not influenced by your expenditure. As you are spending more, your income may not increase. Your income may not increase when you are spending more and more. So, the reverse is not possible in that case. It is only one variable which is dependent, which is independent. The independent variables are to be identified very properly. Otherwise, entire your analysis will go wrong. So, one has to be very careful when we are doing this regression analysis. What is this regression analysis? Regression means stepping back or returning to the average value. Stepping back or returning to the average value is the regression. Regression analysis is a mathematical measure of average relationship between two or more variables. It is the average relationship between two or more. It need not be confined to only two variables. It may be more than that also, multiple regression also there. So once an important list of variables, independent variables and output variable is influenced by various, that is suppose two variable regression. X is the independent variable, y is the dependent variable. Then what is a regression model? We write the regression model as a linear model, a simple linear regression. Of course, there is also a non-linear regression, which we may be taking at a later stage. If you want advanced statistical analysis also, then it is possible. We can have that a separate discussion. Non-linear regression analysis. But here, let us confine to linear regression analysis. So, if we consider two variables only, y and x, x is the independent variable, y is the dependent variable. Then the relationship is y equals to beta naught plus beta 1x plus epsilon. That is, once again I repeat this equation, that is y equals to beta naught plus beta 1x plus epsilon. Here y is the response variable and x is the independent variable or a factor or a dependent or the cause. X is the cause. And here we have a relationship. What is the functional relationship? We have taken as a linear relationship. There is a linear relation. That's why we write the linear equation y equals to beta naught plus beta 1x plus epsilon. Once we have it, now graphically if you look into that, what is this? Beta naught. Beta naught is an intercept. Beta naught is a intercept. What is beta 1? Beta 1 is the slope. If you know mathematically, what you just recollect back, those who have studied mathematics at least at 10th class level, you have this, then you can see beta naught is the intercept for a linear straight line and beta 1 is the slope. So what it is, the interpretation if you look into that. When we see that here the epsilon, what is that? There is actually the relation is beta naught plus beta 1x. But what is this epsilon? This epsilon is an error. Error. Because this error, why it comes? It is due to the sampling fluctuation, due to the various other reasons, due to the other variables. There is an influence of that we call as a residual or an error, epsilon. So we will make assumptions on this epsilon before we make the estimates of beta naught and beta 1 and other things. So the parameters beta naught and beta 1 are unknown to us. We have to estimate these parameters. Estimating these parameters, we have to use that linear. How we will estimate that? We will minimize the error sum of squares. Minimizing the error sum of squares, we will estimate beta naught and beta 1. Beta naught is the intercept, beta 1 is the slope. That means if you see that, irrespective of x, whatever may be the x value, the estimated equation, if I look, y equals to beta naught hat plus beta 1 hat x. So x is 0 if I put there. And what is that? Y equals to beta naught hat. That means there is an influence of beta naught, general effect. We call general effect. Irrespective of the independent variables, there is a general effect on y, on the dependent variable. Suppose if I change 1 unit on x is changed by 1 unit. How many units of change I can expect in y? Because beta 1 here plus I have written positive, there is beta 1 units of change in y. If I change 1 unit on my independent variable, how many units of change I can expect in our dependent variable? Beta 1 hat units. That can be easily seen. So once you have it, we will estimate the residuals and minimize the error sum of squares, that is the residual sum of squares, so that we will get this. Suppose if you have variable and variable 2, 10 observations I have taken, then we can have that. We can do this nowadays. We need not estimate beta 1 and beta hat by doing the mathematical equation, normal equation, solving them, and then we are getting beta naught, beta 1. Doing that, all that has gone. Because now we have statistical packages like SPSS and Minitab. So we can use this statistical package. If you use this statistical package, here what is the simple regression that will be taken care? We will be taking care about, you have to identify this. For example, here if you take the vehicle weight is influenced variable. What is that? Dependent variable is mileage. First you have to select the dependent variable, then the independent variable. Independent variable is vehicle weight. So you have to choose those two variables. You should take into that simple linear regression, because two variable regression is known as simple variable regression, simple regression linear. So then you will have, if you enter these two variables, then if you see that, you will have this sort of output you will get. When you have entered these variables and pressed that regression and choosing the options and other things, you will get this type of output. So this interpretation of this output is very, very important. You may analyze this regression, just the computer output you may get, but interpretation of the computer output is very, very important. Look into this. First, what you have to do, don't go to the first model summary or ANOVA, where you have to go. You have to go for coefficient. First, you have to go for coefficient. For doing that coefficient, what exactly you will have? You have to first see the coefficient analysis. When you see this coefficient analysis, here one important consideration that comes here. Look into this. This is your beta naught. Beta naught, first one, constant. Beta 1, second one. So if you look into the beta naught here, what is that value? 45.492. And what is its standard error? Its standard error is 841. And the t value, we will talk about t value. So the t value, if you look into that, what is this t value? That is statistical test. We have got that beta naught value as 45.492. Now we want to validate whether it is acceptable or not. Beta naught equals to 45.492. Is it be significantly acceptable, or this value appeared because of the sampling fluctuation? If it is due to sampling fluctuation, we cannot take it. Inherent, then only we can accept. So to do that, we have to perform t-test. So the t-test here is performed and we got a t-value. Already you are taught about t-test. So t-test for testing the coefficient, regression coefficient. Here we got t-value 54.110. But this t-value is not important for us in the package. What is important for us? The significant value, if you look at 0.000. This significant value you have to compare with the level of significance. That is your p-value. The significant value here is your p-value. This p-value is to be compared with significance. Suppose your level of significance is 5%. It is you have to compare with 5%. So the significance value 0.000 is less than with 0.05. 5% is 0.05. If it is less than 0.05, then you say that the beta naught is significant. We can accept its value as 45.492. We can accept its value as 45.492. So we have accepted beta naught. Then what is the other value? Other parameter? This one. That other parameter value, if you look into that, what is that? It is negative 0.007. Negative value and 0.007. So when we look into that, minus 0.007 beta 1 equals to, is it be significant or not? Again, we have performed a t-test for that. What is this value? Its value is minus 27.194. So its significant value is 0.000. So this is less than 0.05. So it is also significant. Therefore, beta 1 is minus 0.007 is significant value. Now I got the two parameters. Fine. Is it complete? No, not at all. Then what I have to do? I have to take care before I go for this ANOVA model summary. Just look into the model summary. What is this model summary? This is R square value. This is adjusted R square. If the difference between R square and adjusted R square is more than 10%, if it is difference is more than 10%, then only we accept that our analysis is good. Otherwise, our analysis is wrong, we cannot accept it. Because the residuals that we have taken to minimize is not a sound. We have to see here what is that? It is the difference. If you see, it is 0.001. It is less than 10%, 0.10. Therefore, we can go for further analysis. What is this analysis? ANOVA talk about. We have taken this linear relationship. We have established that. Now we are estimating the model. What is this model? Your y equals to beta naught plus beta 1 x. So, to estimate that beta naught hat and beta 1 hat, these values we got. So here we have assumed there is a linear relation. Whether that linear relation is acceptable or not. So that can be done by F test. The F test significant value, if you look into that. Here it is also 0.000. That is less than 10% or 1%. At 5% as well as 1% or even 1, that it is significant. Therefore, the regression analysis says that the linear assumption that was made and the linear model that was considered is significant. Therefore, we can estimate the relationship y is equals to beta naught plus beta 1 hat x. So, what is beta naught? It is 45.492. Therefore, y equals to 45.492 minus 0.07 x. What is x? X is the vehicle weight. So, if you could change the vehicle weight by 1 lb. Yes. The units are lb. So, if you change it by 1 unit, how many units of change in the mileage will be? Negative. It is decreases, mileage decreases. If you increase the weight of the vehicle, mileage decreases. Vehicle weight is increased by 1 unit, you are getting a decrease of 0.007 mileage liters. That you have to take care. And that is the analysis. This is for 2 variables. That is y and x. If there is only one variable, we can take. Here, what is the another important inference we can make? The adjusted R square value. That is the inference we have to make. We have now the model. What is the model we have? Y equals to beta naught hat plus beta 1 hat into x. So beta naught and beta 1 hat values are given here in this. Now let us look into the relationship. When we look into the relationship, R square, adjusted R square, that is to be taken. The adjusted R square is 0.650. So 0.650 means what is that value? 65%. 65% in the mileage is influenced by vehicle weight. Mileage is reducing when the vehicle weight increases. There is a negative relation. And also not only that, we can establish that 1 unit change in the vehicle weight, 0.07 units decrease in the mileage. And not only that, 65% of that mileage is due to vehicle weight. The remaining 35% is due to other variables. There are several other variables. We may consider type of the vehicle, model of the vehicle and other things. So that is due to the other. So there are also some other variables which are influencing is 35%. It is not even that, it is only 65% only we could be able to explain. Remaining 35% is remaining. There are several other variables which are also influencing. Therefore, one has to identify and do that. For that, we have an analysis known as multiple regression analysis. So, multiple regression analysis, when we look into that, when we have more variables, say k independent variables, more than one, x1, x2, xk independent variables, y is influenced by all these k independent variables. So here y is the response variable, x's are the independent variable. Beta naught, beta 1, beta 2, beta k are the parameters, regression coefficients they are called the regression coefficients. Here we make an assumption because we are doing the tests. When we are doing a test, parametric test, T test and F test are parametric tests. When we are doing the parametric test, we have to make an assumption regarding the error term. So error, what we are making an assumption, it is normally distributed with zero mean and variance 1. Normally distributed with zero mean and variance 1. That is the basic assumption we are making, and we are doing that. And when we are having this, here we can easily see the betas can be estimated by beta hat equals to x dash x inverse x dash y. So once we do this, here this is the linear relation, multiple linear regression analysis. It is a multiple variables we are taking and the linear relationship among them. Non-linearity we can discuss, as I told, at an advanced level at a later stage. So here we have to estimate beta naught, beta 1, beta 2. That can be done by using this formula. So here once we have this is the formula. Here we can have a null hypothesis beta I equals to 0 against beta I not equals to 0. Overall goodness of fit is studied by NO. So here SPSS will be doing. Again I will explain the output more carefully because that is very important we have. So here once you choose the variable. Here if you choose the dependent variable, again mileage, same problem, and then independent variable. What are they? They are taken as time to accelerate. What is the time to accelerate? Horsepower and year of manufacturing. Model we call model year or year of manufacturing. Once we select and we choose that, then we have an output like this. So when we are doing this interpretation, we should be very careful. We will get descriptive statistics. The SPSS output will get a descriptive statistic. What all the variables we have? Vehicle weight, already we have seen. Time to accelerate, horsepower, and model year. These are the, what are the vehicle types? Four independent variables. Now not one independent variable. Earlier we have taken only one independent variable, but we have seen that is only 65% influence on the mileage. But that is not sufficient. So we want to have more and more robust analysis. Hence we have added another 3 more variables. What are the 3 more variables we have added? Time to accelerate, horsepower, model year. Once you do that, now you have to see the correlation matrix. Once you have this correlation matrix, you can see whether they are significant or not. The correlation with respect to the variables. So you have to see the correlation matrix, and once you see the correlation matrix, here you can have whether the independent variables are really independent or not. Is there any dependence among them? So this significant value, this will provide that. Here if you see, these 4 variables are very significant because all are 0, 0, 0. They are really independent because vehicle weight is no way influenced by time to accelerate, horsepower, or model of the year. So they are not influencing. One is not influenced by the other. They are independent variables. So first step is the multiple correlation matrix will provide that, and you have to see the significance of each and every correlation that exhibits between these variables. That is to be taken care of. Once you have it, then you have to come to this model. So when we see the coefficients, here if you see the coefficients, here you have to see what you have to see, the significance. This is very important. So because these are the estimates, now we got this. What is the value? Constant beta naught. First value is beta naught. Second one is beta 1. Third one is beta 2, beta 3, beta 4, like that. So here in the presence of the 4 variables, if you look into that, here what is the significance? This look into that. Here the significance, first one, is less than 0.05. So beta naught is significant. Second one 000, it is also less than. This second one, vehicle weight, is also significant. Those two are very, very significant. Then the next one, look into. It is 0.479. 0.479, what is this value? You have to compare that with what value? You have to compare this with 0.05. 0.05. Therefore, what is your inference? Time to accelerate is not having significant value, even though you got a value of 0.072. This value is not significant. So you cannot include that. You cannot include time to accelerate because it is not significant. The value that you got here is only due to sampling fluctuation. It is not due to the inherent value. It is not really influencing. That is the interpretation we can make with the significant value. Also with respect to the horsepower. With respect to the horsepower also not significant. Also with respect to these two. And the third one, here, model. Model is very important. The model, refinement of the technology, refinement of the methodology in the power or in the manufacturing of part of the thing. So they will do that. So two variables are influencing, the other two are not influencing. So here, even though we have taken 4 variables, only 2 are influencing. What are they? Vehicle weight as well as model of the year. And then coming to this R square, adjusted R square minus R square. The difference is less than 10%. So therefore, our analysis, we can go for analysis. When we see this, it is significant because 0, 0. The linear assumption is also significant, but beta 2 and beta 3 are not significant. We cannot include beta 2 and beta 3. So the model we can write. And what is the interpretation we have? We have the interpretation is adjusted R square is 0.805. Therefore, 85.5% of variation is due to these two variables. That means if you add one more variable of year of manufacturing, it has increased from 65% to 80%. 80%, 65 to 80%. Another 15% variation is there. But still, there is 19.5% of variation due to some other variable, which we have not considered. So we have to look further if you want to further analysis in that. And what is the regression model here? Here regression model is y equals to beta naught plus beta 1x plus beta 4 x4. Beta naught plus beta 1 x1 plus beta 4 x4. That's what we have to take care. And here what is the actual effect? It is 80.5% influence is due to these two variables that we can consider. And also we can see if the year, model year increases positively, it is increasing. What is increasing? Mileage is increasing. Yes. So this is what we can have. And not only this regression, linear regression, we can also use the regression analysis or best set. Because here we have taken 4 and we have done that. So which 2 are to be added? We may have several variables because 15% is there remaining. Only 2 variables we have included. We are not very happy. We want to do as much as possible. So there are several variables will be there. So which are the very, very important variables that have a significant influence and maximizing the R square value. That can also be done by best set regression analysis. This can be done by stepwise, we call. The stepwise we can do as a forward regression or backward regression. Forward regression we will be adding the variables, and in the backward regression we will be removing the variables. We may add or remove the variables accordingly. So when we are doing this, forward regression or a backward regression, we can identify which are the trivial many to vital few. The few variables which will magnify this. So here one click, if you select the variables, all the variables you can select at a time, then you can take this best set. When you do this, you can get the regression in which you can see different models. The output will be provided with different models. Then you will get out of that different models with different combinations of the input variables. which R square is maximum, that model you can take as the best set model. Which R square is maximum, that can be taken. But when we are doing this regression analysis, one important consideration one has to take care before you do that. That is regression diagnostics. Regression diagnostics is whether we are doing this regression, is it be perfect or not? Because this is based on certain assumptions. One of the important assumption is the error terms, that is the dependent variable is normally distributed. Is it be normally distributed or not? Second one is the error, the variables are independent and there is no specified pattern for the error terms. So these are the very important assumptions we are making it. So this is there or not? So we have to do the regression analysis. So for that we can see whether it is there or not. We can plot and we can see the regression analysis. So these are the basic assumptions of the residual analysis. They are statistically independent. That is, the independent variables are all uncorrelated, normally distributed, the dependent variable or the residuals, or they are stable, they are from a stable population, or the variance, equal variation is there or not. This can be done by these four plots, four regression plots. When we take that, we can see whether they are having this or not. So this gives a normal assumption. This is the normal. If it is like a bell shape, then we say they are normal. Or if you plot PP plot, if all are on the line, all on a straight line, we say the normal assumption is meaningful and valid. We can go for regression analysis. That is what we can do that. Once we do that, we have to do the regression analysis very perfect. Another important, suppose if they are not normal, that is if they are not in a bell shape, the observations, dependent variable is not in a bell shape, they are not normal, then what we will do? We have to take more number of observations and we can take a shelter and a central limit theorem. What the central limit theorem says, if the number of observations are more, then the standardized variate will take normal distribution N0, 1. That follows normal if the observations are more. So we have to take more and more variables provided they are unimodal. That is very important. Central limit theorem works only for unimodality. Suppose we are not sure about this using this, then what we have to do? Till we say that they are not in a bell shape, then we have to use transformation. We may take y square, y cube, root y, 1 by y, 1 by root y, log y to the base e, log y to the base 10. Any of these we will take and we will do that. So one of these transformations will make the y variable as normal. Then we will revert back our inferences. We will do all the regression analysis with respect to these transformed variables and then we will convert into the concerned values and we will do that. So this is what exactly we will have, the regression analysis, multiple regression. Of course, there is also, this is for qualitative, quantitative data analysis. Suppose y value is qualitative, then what we have to do? We have to go logistic regression. That is, if they are binary, the dependent variable is binary, then we go that. So we have multiple considerations we will do. Whenever we have an occasion, we may discuss, but this linear as well as multiple regressions, these are very, very important and very useful for our analysis, which we have to take care and we have to do that. Of course, I will be giving you my PowerPoint slides. I will ask Professor Muniswamy to forward you these slides. After converting them as a PDF, we will give you, you can make use of it. Or we will upload in our LMS portal so that you can go through it. They are self-explanatory. You can have, because of the time constraint, we have already the scheduled time as given by our coordinator of this program, Professor Muniswamy, who cannot proceed further. I thank you for the given opportunity. I thank Muniswamy for the given opportunity. Thank you.
Okay, thank you, sir. Thank you, sir. So, dear students, in the for this
RL
correlation with regression analysis. The discussion.
Hello? Hello, I could not get the question.
Sir?
I could not get the question. Any questions are there?
No, sir. Sir is requesting for the students.
Okay. If there are no questions, go through it. Professor Muniswamy, I will forward my PPTs or a PDF format.
Okay,
Please,
sir.
among all the people, students, they can have it and they can go through this. So that if they have any sort of assistance required in future, they can contact me also. I can help them in this part. Okay?
Okay, sir. Okay, sir. Okay,
Thank you.
sir. Thank you, sir, for your nice lecture. You covered all correlation, regression, multiple, simple, linear, and also logistic regression is also covered. Okay, thank you, sir. Thank you very much for your sparing valuable time. Oh, yes.